Hello everyone, welcome to our last new lesson for Pre-Cal Trig X. Today we're learning about polar graphs. Polar graphs, probably something you've never seen before, and it's kind of freaky looking on the graph. But good news, it has real life applications. If, for example, you would look up a microphone that you would want to buy, on the back, if it's a decent microphone, you should be able to see they actually will have polar graphs on there showing how the microphone is able to pick up different sounds from different locations. Pretty amazing. Go ahead, check it out after this lesson. But first, let's move on to polar coordinates. So take out those notes and here we go. First, the major differences between polar and rectangular coordinates is that, well, the graph paper, instead of being, square or rectangular, the graph paper is actually circular. And you've probably seen in some math classes some graphs on the wall that look like spider webs. Well, that's what this is. The coordinates, instead of being x and y, are actually r and theta. So remember, r is the radius and theta is going to be your angle. So we're not talking about distance across and up anymore. Now we're talking about radius of a circle and the angle of the point on that circle. And again, the graphs of polar equations are freaky looking. First, let's just do some easy point plotting or something like that. Point plotting. So first, you'll notice that there's like a zillion different lines coming out of here. I have darkened the important ones for you, and I've put dotted lines on the diagonals, you'll notice. So every diagonal is going to be a multiple of 45 degrees. So this is 45 degrees, or pi over 4. This one is 3 pi over 4, or 135 degrees. This one is 5 pi over 4, and then 7 pi over 4. Then everything else is counted by 6. So there's pi over 6, 2 pi over 6, which is pi over 3. 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6, which is pi, 7 pi over 6, 8 pi over 6, 9 pi, 10 pi, 11 pi over 6. You've got it by now. All right, so now let's move on. This is your r, this is your theta. So we're looking for a circle that has a radius of 2. So we're going to look anywhere on this circle that I'm about to draw. All right, so that circle right there has a radius of 1. This circle right here has a radius of 2. So I'm going to try to draw this circle perfectly. Ooh, that is lovely. All right, so my point is going to be somewhere on this circle. Now, you don't have to draw this circle. We're only looking for a point. I know that this circle has a radius of 2, so it's somewhere on that circle. Now we're going to go to the point on that circle where your angle is pi over 3. Well, this angle is pi over 6. This would be 2 6, which is pi over 3. So this right here, your ring finger, that would be your point. So that's all there was to that one. Let's try another. Again, same deal. We've got to find a circle that has a radius of 5. So I'm going to go out 1, 2, 3, 4, 5. This is our circle, and now I'm going to try to graph it. That's not close to what I said. Let me see with my finger. 1, 2, 3, 4, 5. Nope, that's nowhere close. Well, I'm going to do my best. All right, let's see if I count it correctly. 1, 2, 3, 4, 5. Hallelujah, we got it. All right, so it's somewhere on that circle. I'm looking for the angle. That's my r again. This is my angle. My angle is negative 5 pi over 6. Remember, this negative angle means I'm going to be going down. All right, so we're going to go down by 5 6. There's 1 6, 2 6, 3 6, 4 6, and 5 6 is right there. And that's it. That's all there is to that one. So remember again, positive angles go up and left. Negative angles go down and to the left. Now, there are multiple ways, as you just saw right there, to represent the exact same point. In fact, there are 4 different ways. Let's move on and show you some of those ways. So we're going to assume that all of our angles are between negative 2 pi and 2 pi. We're going to first plot 2, 3 pi over 4, and then we're going to list 3 other points. So what I'm going to do first is I'm actually going to write down 4 points like this, and you'll see why in a moment, hopefully. And put our commas in between, just like that. Now the first one was given to us. These are both positives, so I like to put both positives right here. My other options are, I'll put a plus here and here. So my other options are to have a positive and a negative. I could also have a negative, positive, and a negative, negative, just like that. All right, but before we do that, first, let's go ahead and get this graph done. So I'm looking for 2 for my radius, so I'm somewhere on this circle. Let's see if I can do it. Maybe. There we go. So I'm somewhere on that circle because that has a radius of 2. Now I'm looking for 3 pi over 4. This is a pi over 4 option, so I'm going to be on one of the dotted lines or on an axis. So there's 1 pi over 4, 2 pi over 4, 3 pi over 4 is right here. All right, so that's that point. Now, instead of going up and over, what would happen if I went down and over? Well, let's count the fourths. There's 1, 2, 3, 4 fourths, or pi, that makes sense, 5 fourths. And that was negative, so 5 pi over 4. This still has a radius of 2. You'll agree, right? Great. In fact, I'm going to tell you the radius is never going to change. To reach the same point, I'm going to always have to have a radius of 2. So that's easy. Those are all 2's. In order to get here, the first time I went up and over because it had a positive angle. With a negative angle, I'm going to go down and over. Okay, now it's time for the freaky stuff. A negative r. So we've always said in the past we don't want a negative radius. And here's the reason why. Something crazy happens with a negative radius. So instead of going this direction, the negative radius means I'm going to flop to the other side. So what I like to do is I tell people to draw a ghost point. And there's my ghost. All right, this is not really the point. The real point is here on that red dot. But I'm going to, with a negative radius, I'm going to see how I can get to that point. And then the negative radius means I'm going to flop to the other side. All right, so all I'm doing, trying to get to that point. So let's do it. Here we go. Going up with a positive angle, I'm going to go 1, 2, 3, 4, 5, 6, 7 fourths. So that's 7 pi over 4. And again, once you're there, because we had a negative radius, from that spot, ghosty as I like to call them, we're going to flop to the other side. And that takes us to our point. Now let's go to that point, but instead of going up and over, this has a negative angle. So we're going to go down to that point. So from here on down, that takes us, well, just 1/4. So that's pi over 4. It was negative because we were going down, and then we have a negative radius to flop it over to the other side. All right, a little tricky, but let's go. Let's try another one. I bet you'll get it. In fact, let's go ahead. You go ahead, hit pause, try this on your own, and give it a shot. See what happens. All right, by now you've really enjoyed watching me do that, and we'll do the same as we did last time, plus, 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 minus, minus, plus, and minus, minus. This is always a good idea to do because it gives you all of your different options. Then I'm going to copy the one that was given to me, which is minus, plus, right here. Now, I know I can't screw up the r. It's got to be 8 all the way down because I'm looking for something with a radius of 8. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay. So all I have to do is draw a circle that looks like it's about here. Let's see if I did it. Wow, that was pretty good for me. Great. All right, so there's our radius of 8. Now my goal is to go to, well, pi over 6, which would be right here because it's positive pi over 6. But then that says negative 8. So since that up there says negative 8, I cannot put my point there. That means this is just the ghost. So I would draw a little ghost there. Actually, I'll draw it really light because I don't want people thinking that's my point. I'm just going to draw a little ghost, just like Pac-Man. There we go. There's our ghost. It's not really the point. The real point gets flipped over to the other side because of that negative 8. So I started there, that was my angle, but the -8 tells me don't put it there, put it way over here on the other side. That's where our point really exists. Okay with that? All right, now we have to find all the ways to get to that point from here. Now let's just start with positive, positive, because that's going to be the easiest. So from here, I'm going to go 1, 2, 3, 4, 5, 6, 7 pi over 6. Now this is the negative angle, so I'm going to start here and go down 1, 2, 3, 4, 5 pi over 6, just like that. Now the hardest one is negative, negative. Now because the r value is negative, I'm trying to get to the ghost. All right, don't worry about that point. I'm just trying to get to the ghost. So r is negative, go to the ghost. But I can't go up and over because that's what we already did. I have to go down because this is a negative angle. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. When I went 11 pi over 6 around, that took me to the ghost, and because it's a negative radius, that flops me to the other side of the circle. All right. So now let's talk about converting from polar to rectangular form or from rectangular to polar form. Here we go. So first step, we remember this is r and that's theta, so this is polar. I'm going to rectangular form. So we remember that x equals r cosine of theta. We remember that y is r sine of theta. So those are going to be our formulas every single time, just like it showed you right there. So my x value equals 4 times cosine of pi over 2, and my y value is 4, because 4 was my r, times the sine of pi over 2 again, because that was my theta. Next, I have to figure out what is cosine of pi over 2, so I take out my hand and look at that pinky finger, because it's pi over 2. Cosine at pinky is 0. Then over here, I'm going to find sine at pinky, that is 1. Finally, I have to do the difficult math of 4 times 0, which is 0, and 4 times 1, which is 4. So in rectangular form, that would be the point 0, 4. And if we graph this on the graph, you would have gone 4 for the radius and up pi over 2, so that would have been, your dot would have been up here with a radius of 4. And then if you plotted the point 0, 4 in a rectangular graph, so let's pretend instead of this circular graph here, I plopped a rectangular graph on here, 0, 4 would also be in the exact same spot. Amazing. All right, let's move on to the next one. Go ahead, hit pause and see if you can do this on your own, and then come back to us. All right, hopefully I know you got at least that far. Hopefully you got x equals 2 cosine of pi over 6 and y equals 2 sine of pi over 6. You remember back to colorful snot, c was the cosine value, s was the sine value, so that's your x, that's your y. Next we're going to figure out what is the cosine of pi over 6 and what is the sine of pi over 6. Pi over 6 is that pointer finger. Pointer finger tells us that that is square root of 3 over 2 for cosine and 1 over 2 for sine. Remember, if this is not in quadrant 1, to put the correct sine value, like positive negative sine value, in front of this number. So finally I've got x equals square root of 3, because the 2's cancel. Over here the 2's cancel, and that gives me 1. So your value would be square root of 3, 1. And that would be your rectangular point. Let's go backwards. Let's convert to polar coordinates. So that means this is rectangular, so I'm putting x and y here. Now I have to convert to polar. In order to convert to polar, first we need to know what r equals. We remember that r squared equals x squared plus y squared. So in this case, that's 2 squared plus 2 squared. 4 plus 4 is 8, which is the same as 2 root 2. Did I do that too fast? Maybe. Let's slow it down. So I've got 2 squared plus 2 squared, that is 8. And this was r squared, so I'm going to square root both sides. When I do that, that gives me the square root of 8. I remember that 4 times 2 is 8. Square root of 4 is 2. And the square root of 2 we don't know. Alright, so that's how we got 2 square root of 2. Next we have to figure out what theta is. We remember that tangent of theta equals y over x. So instead of y, we're going to put 2, because that says 2. And instead of x, we're going to put 2 again, because the x value was also 2. Now I know that 2 divided by 2 gives me, you guessed it, 1 is correct. Then, if I know what this value is on my tan hands, which I do, I should use that. So remember, with our tan hands, this is undefined at pi over 2. This is 0 at 0. This right here is pi over 6, so your answer for that is square root of 3 over 3. This is pi over 3, so your answer for that is just square root of 3. And that's pi over 4, which is 1, which leads us to believe that theta equals pi over 4. This was in quadrant 1, so of course I'm just going to leave this in quadrant 1. If this would be in a different quadrant, this would only be my reference angle, and then I would have to put it in the correct quadrant, and that would be it. So finally, remember that polar coordinates have r and then theta. So my r value was 2 square root of 2. My theta was pi over 4. And there is your exact coordinate for polar form. Let's do another. Again, we're converting 2 polar coordinates, so that's your x value and y value. I have to figure out what r and theta equal. You go ahead, give it a pause, try it on your own, and then hit play when you're ready. Okay, here we go, kids. R squared equals -1 all squared plus 0 squared. This gives us 1. So when I square root, I get 1. Or technically plus or minus 1, but we won't worry about that. We're just going to have our radius be 1, because we don't need the confusing -r and then figuring out that angle thing. Over here, I've got the tangent equals y over x, so 0 over -1. Now I have to figure out, where does tangent equal 0? Well, it equals 0 at a couple different spots. It equals 0 right here, but there's also somewhere else where it equals 0. So right here, you saw that this was the point -1, 0. So that means that point is actually right there, not here. So in order to get to this point on the unit circle, I would have to travel an angle of, hopefully you guessed it, pi. So this angle should be pi. Finally, I think we're ready. Oops, why did I just put tangent there? Crazy! Somebody must have some kryptonite here. Tangent of theta, so that's supposed to be theta equals pi. Sorry about that, I forgot to write my theta. Kryptonite, I tell you, kryptonite. Alright, so 1 is our r value, pi is our theta value, and then I am done. So I showed you that example because that one lies right on the axis. It's kind of crazy when it's on the axis, so you have to kind of just draw it and figure out what angle that is. Alrighty then, now we're going to work on equations and converting them. As you can see here, converting from rectangular to polar is pretty easy. You're just going to do some simple changes. From polar to rectangular is rather tricky. So on we move. We're going to convert this one to polar form. So instead of y, we're going to put r sine of theta, just like we did previously, and instead of x, I'm going to put r cosine of theta. Notice that that was squared, so I need to put that squared there. As with all squares, as it is outside parentheses like that, it has to go into everything here, so that r is squared and also the cosine is squared. So this is r squared cosine squared theta. Next, let's go ahead and try to get all of our r's together by themselves. So I'm going to divide by cosine squared theta like this. When I do that, on the right side, all my cosine squareds, boop, boop, all gone. And now I have r. Now, I'm going to kind of separate this just to make life a little bit easier for us in a minute. So instead of just cosine squared, I'm going to leave it as cosine times cosine. You okay with that? Okay, now my fraction is not allowed to be topless, so I need to put something here. I'm going to put a 1. All right, so you would agree that this is the same thing as sine divided by cosine squared, yes? Yes, okay, hopefully you're nodding just like this. Good. All right, so now that equals my r squared value. Now, normally I would not be allowed to do this. However, I know that r cannot equal 0, because if r equals 0, I won't have a radius at all. So I'm going to multiply both sides by 1 over r in order to cancel that. And the same thing here, 1 over r. That will cancel one of those r's and that one on the bottom. So now I have sine over cosine. Well, I know that sine over cosine is going to give me tangent. And I know that 1 over cosine is going to give me secant. And then that's what my r equals. So that's it. Believe it or not, I have converted it to polar form. All right, flip the page. Well, at least for me. Now we're moving on to this one. This one's kind of a freaky one, and we will also maybe graph this one to help you out. We're going to convert this to rectangular form. Right now, it just says r equals 3. So we remember that r squared equals x squared plus y squared, right? So let's square both sides and get r squared equals 9. Now remember, r squared equals x squared plus y squared. So I write it like that. Believe it or not, we are already done. That is rectangular form. So let's think about what this means, and then we'll graph it and show you. This r is the radius. So I'm telling you the radius equals 3. This is the equation of a circle. And remember, the thing over here is r squared. So you'd say that r equals 3, which means a radius of a circle equals 3, which is the same as that. So let's graph this. When I graph this, I'm going to go out 1, 2, 3, and this thing from the center to there is my radius, and then I just have to draw a circle. So, easier said than done for me, but let's see how this goes. Now I'm going to try to draw a circle. Well, that was close enough. Okay, now that circle is my answer. You don't have to draw the radius if you don't want to. I can get rid of it just like that. That is my graph. So instead of graphing a point, since this was an equation, it's a line, except it's not really going to be a straight line. In this case, it's going to be circular, although there are times when you could graph straight lines in polar graphs. Speaking of that, let's do it. On we go here. I have theta equals pi over 3. Theta equals pi over 3, so I know that tangent of theta equals y over x. So here I know that the tangent of pi over 3 is the same as theta equals y over x. Well, what in the world is pi over 3? Hopefully you're taking out your tan hands and you know that the square root, the tangent of pi over 3 is the square root of 3. And you know that the square root of 3 is same as the square root of 3 divided by 1. So I'm going to cross multiply here. That gives me y equals the square root of 3 times x. Hey, we're done. It's already in rectangular form. You have a y and an x. You always know that something's in rectangular form when you no longer have an r or a theta. All you have are x's or y's or both. So I'm all finished. Believe it or not, that square root of 3 over 1, or square root of 3, is the slope for this line. So if I graph this, this would be the same as the square root of 3 times x plus 0, right? So your y-intercept would be 0, and your slope would be square root of 3, so you'd go up square root of 3 and over 1. We're going to do the same thing with this graph. With this graph, my y-intercept is here. Now, this is not a rectangular form, so let's go ahead and figure this out. This tells us that our angle is pi over 3. So on this graph, I'm going to graph anything that's on the line pi over 3. So pi over 3 is this line right here. You agree? Yes, good. Okay, so all I'm doing is I'm graphing a line at pi over 3. Let's do it. Boom, just like that. That was maybe a little thicker than I was hoping for, but that's okay. So it's on that line anywhere. Again, this is an equation, so we know it's going to be a line of some sort, not just a point. In this case, it is this line right here. Now, if I would magically take a rectangular graph and plop it onto here, so this is going to be kind of hard to imagine, but let's see if we can do it. So this is like 1, 2, 3, 4, 5. Going across, this is 1, 2, 3, 4, 5, like that. And let's see if I can get rid of this. Can I get rid of that? Yeah, sort of, I did. All right. And my line looks sort of like this. And like that. All right, that's beautiful. All right, square root of 3. So on my calculator, I'm going to type in the square root of 3. That's like, I don't know, 1.7 or something. So 0, 0 was my y-intercept. And then from there, I'm going to go up like 1.7 and over 1. And you'll notice that that's right on that line. So rectangular equation, exactly the same as the polar equation, like this. Amazing. All right, let's move on. We're going to convert this one to rectangular form. So you're going to just use whatever tricks you know in order to make this happen. In this case, I know that secant is the same thing as 1 over cosine. So I did that. And hey, you know what? I see an r and a cosine, and I would love for r and cosine to be together. So I'm going to go ahead and cross multiply. All right, the reason why I want r and cosine together is because I remember that r cosine of theta is the same thing as x. So this would be the same as the equation x equals 1. So if I had to graph this, let's just think of this as a rectangular. So ignore all the circles. Let's let that be 1, that's 2, that's 3. This is rectangular. If I had to graph the equation x equals 1, let's draw my line here, my line there. Perfect. Okay, so let's hide this temporarily so you can't see it. It's gone. All right, so if I had to graph the line x equals 1, I would go over here to the x equals 1, put a dot, and here are all the spots where x equals 1, anywhere on this vertical line. All right, so that would be x equals 1. Now let's go to polar form. Boop, back it goes. And this would be the exact same graph. This is the same as the graph of r secant of theta. Beautiful, isn't it? Okay, before we move on, let's move on and talk about the calculator and how it works. So right here are your instructions on how to convert a rectangular or polar coordinate to the other. So you could start with polar and then go to rectangular, or start with rectangular, go to polar. Either way, the calculator will actually do this for you. So let's scroll on back and go to the ones that we've already converted. So like way back here to 4 and pi over 2. We can do this on the calculator. All right, so 4 and pi over 2. You keep that page there and I'll show you this. So 4 pi over 2, let's write that down because I'm old and forgetful. 4 pi over 2. Now this was my r, this was my theta, and my goal on that page was to convert it from polar to rectangular form. So to go from polar to rectangular form, the big P stands for polar, big R stands for rectangular, and if I want to know what the x value was, here's what I'm going to do. First, turn on the calculator. Step 2, go to polar as the mode. So hit mode and go to polar. Yours may say pol or polar, depending on how fancy pants your calculator is. After that, just hit second quit. Then you go to second angle, the apps button, and we've already used numbers 1, 2, 3, and 4 on this screen before. We've used degrees, minutes, and, ooh, I lied, we didn't do 3 yet, but we did do 4, degrees, minutes, and seconds conversion. Now, we're only looking at options 5, 6, or 7. So in this one, we were going from polar to rectangular, so I'm looking at option 7 here. So hit enter on 7, or just hit the number 7. Now this one is asking me what is the coordinate. So you're just going to type in this exactly the way it looks. Now yours probably starts this parenthesis for you. Again, mine's not super fancy because I just came from the planet X and I don't have super fancy calculators like some of you graphing in color. Crazy. So anyways, we start with the parentheses, go ahead, type the number 4, and then the comma button. Comma is above 7, and then after that I'm going to type pi. Pi is above the division key. You're going to have to hit the second key first, and then divided by 2. End your parentheses, then hit equals, and you should get the answer of 0. Alright, so remember, if we're converting it into rectangular form, we know that our x equals 0. Now we're going to do the exact same thing. What I like to do is I just hit second enter, so I get the exact same thing that I started with, and then I scroll back and make my blinker go on the P, and then we're going to go hit second angle again, and instead of option 7, now we're going to do option 8, the y value. And now when you hit enter there, you should have the P arrow R Y, and then that point that you already typed above. So hit enter, and that should have 4 for your answer. So our point there was 0, 4. And if you noticed, when we did this problem long ago, oh, it seems like weeks ago now, right there, our answer was indeed 0, 4. Now the good news is, when it's a nice, pretty answer like this, it's easy to do with a calculator. The bad news is, when you have an answer like this, and it's a square root, your calculator will only give you the decimal, so it's going to be up to you to figure it out by hand. Alright, now let's go backwards. Let's go from polar to, from rectangular, to polar form. So right here we have the point 2, 2. Let me write this down before I forget. Alright, we did that one already. Let's change to red. We had the point 2, 2 in rectangular form, so this is x and this is y. My goal is to figure out what r and theta would be. So to do this, I'm going to hit second angle, the apps key again. This time I'm going from rectangular to polar, so I need options 5 and 6. So go ahead, hit option 5, and then in there I'm going to just type in the coordinates again, 2, 2, and then end the parentheses. Then hit enter, and when you do, you should have gotten something like 2.828. Then for theta, I'm going to hit second enter, remember, go back to the R, put your blinker on the R, and change this to the theta value by hitting second angle, and this time you're looking for option 6. And there we should have 0.7853 something something. Okay, I don't know if this makes any sense to me, so let's go back to our answer for this one, for 2, 2. See if I can find it again. 2, 2. Where did it go? There it is. So my answer was 2 square root of 2 and pi over 4. 2 square root of 2 and pi over 4. Like that. Alright, so in my calculator, let's go ahead and hit 2 square root 2 and equals. And you notice that's exactly the 2.828 number that I had before. Then let's just type in pi divided by 4 on the calculator, and you will notice that's the same 0.87 or 0.785398 blah 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 number that I had before. So this is a great way to check your answer. So easy. Now let's go ahead and let's try graphing one of these functions. Now I had you do something earlier to put it so that we could do some graphing, and that is when I told you to go ahead and change it to polar form in mode. So when you go to mode polar, this will allow you to do polar form. Now right here, this is in rectangular form because it's x and y, but if I wanted to change this into polar form, I could just type this number in. So right here we had r equals 3. So go ahead, hit y equals, and you'll notice that instead of y equals now, the calculator is telling you r equals. So we're going to say r equals and just type in a 3 and enter. Next, I'm going to go to the window. My window. I want my window to go 0 for your x minimum, or your theta minimum, sorry. Your theta max is going to be 2 pi, and after you hit enter, it's going to turn it into a decimal. That's okay. Our theta step, you want it to be something really small, so maybe like 0.1. Remember, that step is telling the calculator how often to take a picture of your graph as it's being, graphed around. So 0.1, that would be fantastic. So you can think of it as every 1/10 of a second is going to take a picture. Then your x min and x max, I'm just going to do -10 to 10, +10, and count by ones. Your y, I'm just going to go -10 to 10 and count by ones again. All right, so this allows you, well, you'll see what happens. All right, go ahead, hit graph, and you should have a beautiful circle. Now, it's not quite going to look like a circle because your graph on your calculator is rectangular and it's kind of squatty. So it'll look kind of like an ellipse, but if you look, it's going to hit the x-axis at 3 and -3, and it's going to hit the y-axis also at 3 and -3, which shows you that really is a circle. All right, and it should give you that beautiful graph there. Going back to this one, we had theta equals pi/3. Now notice there was no r value, right? So it's kind of like in rectangular form, if you wanted to graph x equals something, it doesn't work. So for this, it doesn't really work. So you would have to convert it to rectangular form and then graph it like that from the y equals by changing your mode to rectangular. That's kind of a pain. All right, so now you know how to graph stuff. If you're not sure, let's go ahead and graph this one on your calculator. Go ahead, I'll give you a second, hit pause, and then come back. All right, so on my calculator, I've got the r equals, I hit y equals to get there. I've got r equals secant of theta. Now secant, there's no secant button on my calculator, so I do 1 divided by cosine of theta. Where's the theta button? All you have to do is hit the normal x button, and you'll notice it's theta in this form. Amazing. All right, hit equals and then hit graph, and you should notice a line going boop, straight down across the what would be x equals 1 on the rectangular graph. All right, so those are all the cool tricks I have to show you for that. Next, we're going to go on to graphing more serious polar equations. So if you want to go take a break, now would be a good time to run around the block, get some energy, because this one's kind of a longer session. Sorry about that. Here we go. All right, on we move to polar equations. This is going to be the coolest thing. You're going to see some graphs you have never seen before, and you will be amazed. All right, I know it's hard to believe, but wait till you see it. You will go, oh, wow, that was kind of cool at some point today. All right, so here we go. We're going to graph all of these. Now, I've switched the r and the theta just because I'm going to give you what theta is, and we're going to figure out r based off of this equation. So it's kind of like r is the y value. Kind of like, so in the graphing calculator, we have r equals for all of our equations. Usually you'd have a y equals for all of your rectangular equations. All right, so here we go. We've got -4 times the sine of theta. So in this case, I've got -4 times the sine of 0 is 0. So -4 times 0 is 0. All right, so all of these are going to be -4 times whatever the sine of that angle is. So I can just copy -4 and then parentheses about 1.5 zillion times it looks like here. All right, this is going to be a mess. All right, so -4 times all those things. I'm going to be a little bit lazy and copy and paste as you're doing this, so go ahead, keep copying that, and I'm going to paste it just like this. Boop. Nice. I know you're a little jealous. Get rid of that 0. Good enough. All right, so now we're going to just plug in all of those values. So pi/6, what's the sine of pi/6? Hopefully you already know that's 1/2. And the sine of pi/3 is the square root of 3/2. Sine of pi/2 is 1. 2pi/3 has the same value as pi/3, and it's in quadrant 2. And if we remember, antelopes sometimes tackle children. So we're over here in the sometimes quadrant, which means that sine is positive. So this is going to give me the same answer as 1pi/3. And the same thing, 5pi/6 goes with pi/6. Okay, the sine of pi is going to give me 0. Now 7pi/6 goes with pi/6, but we're in quadrant 3 where sine is negative. And also in quadrant 4, sine is also negative. So I know that all of these are going to give me negative values. Now next I've got the square root of 3 over 2 because this is the same as pi over 3. This is the same as pi over 2, so that's going to give me 1. This is the same as pi over 3 again. Pi over 3 is the same as square root of 3 over 2. This is the same as pi over 6, but negative again, so it's 1/2. And then 2 pi is the same thing as 0, so I'm just going to put a 0 here. Alright, so 2 pi and 0 should give me the same answer. Next, I'm just going to multiply all these. So this is -2. This is -2 square root of 3. This is -4. This is -2 square root of 3. This is -2, 0, 2, 2 square root of 3, 4, 2 square root of 3, and 2. Whew, that was a lot. Alright, hopefully you can see behind my head. Alright, so next I'm going to just plot all of these points on my graph. It is going to be beautiful. Now I know these are a lot of points, but that's alright. You're big. You can do this. Alright, notice that all of these are counted by 6. So 1, 6, 2, 6, 3, 6, 4, 6. So we're not even going to use the diagonals. We're just hitting all of the other lines, not the diagonals. So 0 goes with 0. So 0 is my radius, 0 is my point, there. All right, -2 for a radius, pi over 6. So pi over 6 is this line here. I'm going to go out to the 2, but because my r is -2, I'm going to flop to the other side. So there's my first point. Next point, I'm going to go to pi over 3, which would be this line here, and 2 square root of 3. Shoot, I don't know what 2 square root of 3 is, so I'm just going to hit second quit on my calculator. 2 square root of 3. In decimal form, that's about 3.46. Or I'm not quite that accurate, so we'll say 3.5. So this is the same as -3.5. So again, I'm going out 3.5, but since it's negative, I have to flop this direction 1, 2, 3.5 like that. Next, I've got pi over 2, which would be up here, and then -4. So the negative tells me to flop down again, 1, 2, 3, and 4. Now, some of these graphs are going to get kind of confusing, and so it might be a good idea to kind of draw these as you go, but we'll do that in just a moment. So right now we just have these 3 dots right here, and it should go in this order. Okay, next we have 2 pi over 3. That's this line right here, and my value was -2 square root of 3, which is -3.5. There's 1, 2, 3.5, but I have to flop to the other side to 3.5. Then I have 2 pi over 3. Sorry, I just did that. 5 pi over 6, I mean. 5 pi over 6 is this line right here. And then I've got to flop over to -2, which would be there. Okay with that? No problem so far? Great. Next we have pi and 0. So pi would be over here, but my radius is 0, so I'm going nowhere. So that would be right there in the middle, that same exact point. 7 pi over 6 would be this line right here, right? And I'm going to go out 2. 1, 2. Oh, it's that same point. All right, next 4 pi over 3, which would be this line right here, and 3.5. 1, 2, 3.5. Huh. You notice that we're hitting the exact same points. 3 pi over 2 is here. My radius was 4. 1, 2, 3, and 4. Pretty amazing, isn't it? All right, so you should notice that our graph should look something like this. I'm going to try to connect the dots, but my connecting skills are pretty horrible with this pad. All right, so it should look something like that. Amazing. Now, don't worry, that's not the cool graph yet, but if you're impressed by that, just wait till we move on. There's going to be 3 different types of symmetry here. Symmetry with respect to pi over 2. So this is the line pi over 2. So if it's symmetric about pi over 2, that means this point right here would be also over there. Kind of like when we had parabolas. If we had a point here, you know that across the axis of symmetry, we'd hit that same point. Another way to write this would be -r negative theta compared to r theta, or r comma pi minus theta. Next we've got symmetry with respect to the polar axis. This axis, what's usually the x-axis, is now going to be called the polar axis in polar land. So if it's up here, then we would flop over that axis. So instead of x-axis symmetry, this is considered polar axis symmetry. So you can think of the polar axis as being like x-axis symmetry. You can think of pi over 2 as being like y-axis symmetry when we're talking about rectangular. Next, symmetry with respect to the pole. We're going to consider the pole to be this right here. So basically we're just going to take our r theta, wherever that is, and we're going to flop it to the other side. What flops it to the other side? Having a negative radius. So all you do is you change the sign of your radius and it will flop to the other side. Those are the three types of symmetry. There are different ways to test for symmetry, but those are my hints to you. Now we're going to use symmetry to help us sketch this. Ooh, but before we do, wouldn't it be nice if the calculator graphed this stuff for you? Great news, it does. So hit the on button on your calculator, hit y equals, and then for R1, hit clear and type in -4 sine of theta. Remember, the theta is the x button. Hit equals, and then go ahead, hit graph, and you should see this exact same circle that we just did. Now let's move on to another problem, and I will help you out with this. We've got r equals 2 plus 4 sine of theta. So go ahead in your calculator, hit 2 plus 4 sine theta. Now we need to fill in this chart. So in order to fill in the chart, we need to set up our table. So hit second window, you'll know above that, it says table set, and we're going to set this table up. Now you want to start at 0 because our XY chart is starting at 0. We're counting by, it looks like I've missed a couple. So if yours looks like this, it's not supposed to. We're missing a couple 6. So that's 1 6, 2 6, 3 6, 4 6, 5 6. My 6 were somehow deleted from this. So make sure you have 5 6 and 1 6 in there. We're going to count by pi over 6. So in the delta table, or the little triangle looking thing, table, we're going to change that to pi divided by 6. And when you hit enter, it's going to change to a decimal like 0.5235987 something something. Great, now we're all set up. So hit second table, that's the graph button. The second graph gives you the table. And you'll notice on the left side, the first number we see is 0 and then 2. And then each of those numbers after that are decimals. And you'll notice that 3.14159 blah 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 is the very, well for me, the very bottom. I don't know if your calculator works out the same way, but locate 3.14, which is the same as pi, and then right there, that had a value of 2 also. So notice that every time we hop, it's going to be by 1/6 of a pi. So there's 2, this one was 4, this one was 5.4641, which is close enough to 5.5 when I'm graphing. This one was 6, this one was the 5.5 again, and here this was 4. Okay, you'll notice that there's some symmetry right about here. Everything is the same on both sides, correct? Great. All right, so if you hit graph, you will see that we do indeed have some symmetry, but don't just do a Zorro graph. We need you to actually graph the way that these points are telling us to. So let's start with the point 0, 2. We go, 0, 2. So don't think of 0, 2 as being this point right here. That's in the XY realm. Remember, this is really the point 2, 0, because we always put r first and then theta. So this is really the point 2, 0 here. So I'm going to go across to a radius of 2. I'm going to go to the angle 0, which is right there. Next I've got pi over 6 and 4. So pi over 6 is 1, 2, 3, and 4. Then next I have pi over 3, which is this line. I'm going to go up 5.5. 1, 2, 3, 4, 5.5. Next, pi over 2 takes me to 6. So there's 2, 4, and 6. And then 2 pi over 3 takes me to 5.5. 1, 2, 3, 4, and 5.5. 5 pi over 6 is this line here. It goes out to 4. 1, 2, 3, and 4. And then pi 2, 1, 2. Okay, now it's easy to see that we have this part, and again I'm going to try to connect the dots. Oh, but my connecting skills are pretty terrifying. Alright. Like that. Okay, now in the previous one, we didn't have any points that were crossing this axis. So it was pretty easy to make that beautiful thing that turned out to be a circle. In this case, we're crossing an axis. And normally when that happens, well, something freaky will happen. All right, so again, you notice that this is symmetric like we had planned. We said that right here, it looked like at pi over 2, we were going to have some symmetry. So this definitely has pi over 2 symmetry, but we're missing some information here. So let's go back to our XY chart and see what happens after that. Okay, after this point, after pi, let's keep going. So hit second table on your graphing calculator and find the 3.14 and then go just past the 3.14. That'll take us to our next sixth. So it'll be somewhere on this line, 7 pi over 6. Notice this one says 0. So I'm going to plot the point right there at 0. So I now know that my line is going to curve like this. We always do nice smooth curvy lines. All right, our next one would be here on this line, but it's at negative 1.5. So instead of being here at positive 1.5, we're going to flop over to the other side. So there's negative 1.5. So I'm going to continue on my curvy smooth line. Now I'm going to hit go to the next line down again on the calculator. That's negative 2. So we would be here, but since it's negative 2, we're flopping over there. Our next line would be here, but instead we're going to flop to the other side. 1.5. 1.5 is here. Next we would be here at 11 pi over 6, but instead it says 0. So I'm going to put it out here at the 0, connect the dots. Boop. And finally at 2 pi, which is 6.28, you should see the number 2 next to that. So 1, 2 would be 2 pi, oh, right there in that exact same spot. So then we connect those dots and we got this. Now if you hit graph on the calculator, you should see this exact same thing that has this little kind of a circular thing inside of a circle. Nifty, huh? We're still not to the coolest one yet. Hang in there. All right, so again, when you're graphing this, use the numbers in the chart. Don't just do a little Zorro graph where you're just going woo and just kind of drawing little circles. All right, you go ahead, hit pause, type this on your calculator, and come back. All right, hopefully you've typed this on your calculator. Now, I'm also trusting that you can not only type it on your calculator, but you could also graph it and find those values. But before you do, if again you're missing a pi over 6 and a 5 pi over 6 on your paper, you should write those in. I think they were missing. All right, you go ahead, fill in those values. Let that help you out, and go ahead, get the second half and graph the whole thing. Go ahead, hit pause. I'll wait here for you. Okay, here we go. We're back. So I hit second graph on my calculator. On my calculator, I'm starting at 0. That gives me 5. The next one was 4.7. And then 4, 3, 2, 1.31. This doesn't seem to give me much symmetry. Well, let's give it a shot. 0, 1, 2, 3, 4, 5. Looks like it's right there. Pi over 6 and 4.7. 1, 2, 3, 4.7 is way up here. Pi over 3 is this next dark line. It's at 4, 1, 2, 3, 4. Notice I'm not really even counting which line is which. I'm just going to my next solid line every time. Pi over 2 is at 1, 2, 3. 2 pi over 3 takes me to 2. 5 pi over 6 takes me to 1.3. Pi takes me to 1. All right, so far, I don't know if I can see much symmetry. I'm going to again try to connect those dots. Oh, it's pretty scary when I do. All right, well, close enough. All right, we have that so far. So something tells me from the looks of this that maybe, well, my symmetry is definitely not here like the last one. Maybe it's going to end up being here. And a good hint to that is that this one only had a sign right there, and it was symmetric. It flopped over what used to be the y-axis and now is considered the, you guessed it, 3 pi, or the pi over 2 axis. Now this time it would be going right here over the polar axis. All right, let's see if that actually happens. So on my calculator, I'm not writing all these down, you notice, in the XY chart, because the XY chart given to me just stopped there. I could keep going if I wanted to, but I'm just going to just count along. So my very next one on the calculator goes to this dark line, and it had 1.3. So I'm going to go 1.3, which is here. My next dark line is here, and it was at 2. My next dark line is here, and it was at 3. My next dark line is here, it was at 4. Next dark line is here, it went to 5. Oh, 4.7, sorry. My next dark line is here, and that went to 5, which is where my point already is, so that's a good sign. So I'm going to connect those dots. Pink and pink. Ooh, that's pretty. It's got a cute little dimple there. All right, hopefully you are A-okay with that one. Let's go ahead and try this one on your calculator. Go for it. The only major difference is we changed that to a minus sign. So you should just be able to hit y equals, change the plus to a minus, and see what happens. Okay, hopefully you were able to do this on your calculator by now. All right, I'm starting with 0. This gives me 1, 1.3, 2, 3, 4, 4.7, oops, and 5. This again is going to have that same symmetry going across. 0, or 1, 0 technically is right there. Pi over 6 is here. I'm going to go to 1.3. Next line takes me to 2. Next line takes me to 3. Next line takes me to 4. And then 4.7. And then 5. So it looks similar to the last one, except this time we're going the other direction. Hey, not too bad for me. Then I'm going to continue on with my calculator, find the first one under 3.14. That took me to 4.7. So 1, 2, 3, 4.7 is there. And then the next one was at 4, 3, 2, 1.3, and then 1, which is back on that same point again. Okay, good enough. Well, let's pretend I hit those points. On we move to the next one. We've got 1 minus 2 cosine of x. I have a feeling that you would be able to do this. Go ahead, graph it on your calculator just to see what happens. And what do you notice this time? This time it looks a whole lot like that one, except it's sideways. All right. On we move. We've got something different happening this time. This time, let's go ahead and graph this. This one is 4 cosine of, this time it's 2 theta. Now we're getting to the ones where you are going to be amazed. All right, 4 cosine of 2 theta. All right, so on my calculator, I go ahead, type that in, and here's what I get. I get 4, 2, negative 2, negative 4, negative 2, 2, 4. This one gives me 2, negative 2, negative 4, negative 2, 2, and 4. There, my 4 didn't want to come out. All right, let's graph this one and see what it looks like. This one is going to be your favorite. So 0, that's on this line, 4. 1, 2, 3, and 4. Next one takes me to 2. Next one, negative 2. So I should be on this line, but instead I'm going this direction, 1, 2. All right, so my graph started here, and then went here, and then went all the way over here. All right, next I go pi over 2, which is this direction, but it's negative 4, so I'm going this way, 1, 2, 3, 4. All right, this is one of those where you're definitely going to want to kind of connect the dots as you're going. All right, 2 pi over 3, which is the next line. It should be here, but it's negative 4. 1, 2, 3, 4. I'm sorry, it's negative 2. 1, 2 is what I meant. Next, the next line would be here, but this says positive 2, 1, 2. So I didn't flop because it said positive. So I'm going to go like this, trying to make this as pretty as possible. All right, so that was 5 pi over 6. Now I'm going to pi and over 4, 1, 2, 3, and 4. The next line takes me to 2, 1, 2. I'm trying. My next line takes me to negative 2, so it should be here on this line, but I'm going to negative 2, so I'm going 1, 2 like this. And then my next one takes me to negative 4. It should be on this line, but instead I'm going this way, 1, 2, 3, and 4. And then next I've got the next line, which would be here, and it says negative 2, so I'm going to flop this way, 1 and 2. And then 11 pi over 6 is this next line, and it says positive 2, so that's 1, 2 right there. And finally 2 pi goes to 4, which is there, that same point that I started with. All right, that looks pretty beautiful. If you hit graph on your calculator, you should see the exact same thing. Well done. All right, on the next slide you see, and next 3 slides actually, you see all the different types of graphs that you could create. This is called a limmason, and this is where a divided by b is less than 1. This is when you have some number plus another number times the cosine or the sine. All right, so if a over b is less than 1, in other words, if b is bigger than a, then you're going to get a limmason with an inner loop. If a and b are exactly the same number, then you're just going to get this cardioid. It's a heart-shaped graph. If a over b is between 1 and 2, you're going to get a dimpled limmason. So instead of having this loop in here, you're going to have a little cute little dimple. And otherwise, if a over b is bigger than 2, you're going to get this weird looking thing, looks kind of like an egg. Do you have to memorize those? No, I'm just showing you, so just in case you would, I don't know, want to do a promposal next year. Hopefully we'll have prom next year. If you want to do a promposal next year, maybe you could create a lovely flower for the girl you were asking. So if you want a 3-petal curve, you would put a 3 right here. If you would want a 7-petal curve, you'd put a 7 right here. This is going to work for any odd number. However many petals you want, if you have an odd number, you put that odd number there. Now you're going to take the number of that you plug in and double it if it's an even number to figure out how many petals. So if I put in a 2 right here, since 2 is an even number, that's going to give me double the number of petals. It's going to give me 4 petals instead. Freaky. All right. You can also draw circles like the first one we did. This is where it's cosine. That one is where it's sine. Then I don't even know how you pronounce this one, but let's just call it a lemniscate. I don't know. But this is when r squared equals a squared sine of 2 theta, and there's the one for cosine of 2 theta. Sine has a diagonal, cosine is horizontal. All right, finally we want to sketch this graph, and honest to goodness, I do mean finally. This, my friends, is our last new notes problem ever. It's very sad, isn't it? All right, here we go. Go ahead, type this on the calculator, but this time we have a problem. Notice that this one says r squared. So we're going to have to do 2 different things. We're going to have to square root both sides so that we can figure out what r is. But when we square root in r squared, that gives us a plus or minus. So this is going to give us positive square root of 16 sine 2 theta and this is going to give us negative square root 16 sine of 2 theta. So this is going to be your R1, and that's going to be your R2. Go ahead and type that into your calculator. Go ahead, I'll wait for you as I'm typing it in myself. Make sure you're typing that negative on the outside of the square root, otherwise you're going to get some sort of crazy error and your calculator may explode. Alright, you're ready to go. So hit second table, and this time you're going to have two different R values depending on which one of these functions you're doing. So 0 goes with 0 for the first one, and then 3.7, 3.7, 0. Then you're going to have an error here and here, and then pi is going to be 0. Let's go to 7 pi over 6. 7 pi over 6 is going to be 3.7, and then this is going to give me 3.7 and 0 and error again, and then error again. All right, I think we've got this. All right, we're ready to graph. Now this again is only the positive values. Let's do it. 0, 0 goes right there. This line goes up to 1, 2, 3.7. Next line, 3.7. This one goes back to 0. Alright, so we've basically done something like this. Alright, good with that. Now we have no solution stuff, so that means there's going to be nothing here. So we're just going to kind of lift our pencil and start again. Pi would be this direction, but it's 0, so I stop there. 7 pi over 6 is this line, and I'm going to go out 3.7, 1, 2, 3.7. Next, 4 pi over 3, also 3.7. And then next, 0. So I'm going to go from here out and around and like that. And notice I have error, 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 so I don't do anything else there. That's all I've got. Now let's do the negatives. So in the R2 column, let's go back up to 0. In the R2 column, I have 0, negative 3.7, negative 3.7, 0, error again, error again. Then at 3.14, that's at pi, that gives me 0, negative 3.7, negative 3.7, 0, and then errors all the way down. Alright, so let's graph 0, 0. That's here. Pi over 6, which would be here, but it's negative 3.7, so I'm going to go this direction. 1, 2, 3.7. It's that point. That's nifty. And then pi over 3, negative 3.7. This way, but since it's negative, I'm going 1, 2, 3.7. Wow. Pi over 2, 0, which is going to be there. Skip. Then I've got pi 0, which is that point again. 7 pi over 6, negative 3.7, so it'd be here, but now I have to flop, and it's that point. And hopefully by now you've noticed that we're just copying all the same points again. So both of them give us the exact same answer. So that's it. That's our beautiful graph. And we kind of knew this already because it was in the form of this guy. All right. Thank you very, very much, everybody. I hope you have enjoyed my alien form, giving you all these notes. Sorry for how long it is. I hope you guys have a wonderful day. Thanks for your hard work. I'll see you next week for a very short video. Thank you very much. Goodbye, everybody.